Hello, here we're going to be looking at converting recurring decimals to fractions. So the objective here is to convert recurring decimals to fractions using algebra. So here's an example. So we need to convert 0.2 recurring to a fraction. So what we first do here is we define 0.2 recurring to be some value x. So we say let x equal 0.2 recurring. 0.2 recurring basically means 0.222222, so on and so forth to infinity. So I'm going to put a bunch of 2's here to show that it's 0.2 recurring. Now what we do is we find 10x. So 10x, if x is 0.2 recurring, 10x is going to be 2.2 recurring. So all I've done here is I've moved the decimal place one space to the right. So now what I can see, if I subtract 10x from x, I end up with 2.2 recurring minus 0.2 recurring. The recurring part cancels and I'm left with 2. So that's the objective here. We want to get rid of the recurring part because the recurring part is quite difficult to work with. So we now have 10x take away 1x, so that's 9x equals 2. So if 9x equals 2, that means that x is going to be 2 over 9. So if x is 0.2 recurring and x is also 2 over 9, then we can therefore say that 0.2 recurring must be equal to 2 over 9. Here's another example. So this time we have 0.45 recurring. So again, I'm going to let x equal 0. And I'm going to write down the first couple of digits. So I'm going to write 4, 5, 4, 5, 4, 5, 4, 5, so on and so forth. So now, as usual, I'm going to work out what 10x is. So 10x is 4.545454. Now, this is an issue because if we try and cancel them, it's not going to cancel out because we've got 5, 4 and 4, 5, so they're not the same. So then we need to go one step further. So we need to find 100x. So 100x is going to be 45.454545. And that's great because now we have a 4545 and a 4545 over here. So if we subtract them, in other words, if we take 100x and we subtract x, we end up with 45.45 recurring, take away 0.45 recurring. So we end up with just a nice old 45. 100x take away 1x, that's going to be 99x. And if 99x equals 45, then we can say x equals 45 over 99. That fraction can actually be simplified to 5 over 11. So if x is 5 over 11 and x is also 0.45 recurring, we could therefore say that 0.45 recurring is the same as 5 over 11. So here's another example. So this time we're converting 0.583 recurring to a fraction. If the dot is just on the 3, it means that the 3 part is the only part that's recurring. So I'm going to let x equal 0.583333. So I'm then going to find 10x. So 10x is going to be 5.83333. And then I'm going to work out 100x. So 100x is 58.3333. Now still nothing's cancelling because I've got a 333 here, an 8333 here, and a 5833 here. So I then need to carry on going. So I need to go one step further. So we have 1000x. So 1000x is going to be 583.3333. And now it's good because I've got the 3 recurring over here and the 3 recurring over here. So if I subtract them, the 0.3 recurring part's going to cancel out. So I'm going to do 1000x minus 100x. And I have 583.3 recurring minus 58.3 recurring, and that's going to be 525. So 1000x take away 100x, that's going to be 900x. So if 900x equals 525, I could therefore say that x equals 525 over 900, which is the same as 0.583 recurring. This fraction could probably simplify. It doesn't specify that we have to simplify it, so for now I'm just going to leave it like that. So here are some quick fire practice questions on this topic. Pause the video, have a go at these, and I'll reveal the answers in a moment. Okay, so well done if you managed to have a go at those. I've just displayed the answers on the screen, and that's everything for this video. So well done if you had a go at this, and I'll see you again in another video. Bye!